Hi guys, and welcome to my YouTube channel. Now, in today's video I'm going to be showing you Hello World in C and explaining everything I do. Now, the first thing we want to do is make a file. What we're going to do is we're going to call this helloworld.c. So, my terminal, I'm going to just go into a new folder. I'm going to call it video hello world. cd video hello world. Then I'm going to open Vim on hello world. And it's .c because it's a C file. Now the first thing you need to do is include stdio. This is the standard IO library. Now you need to include stdio to get access to functions to print to standard out or std out. So we're going to use hashtag include, then in the angled brackets stdio.h. Next is we need a main function. Now we're going to type int space main, then in brackets we're going to put int argc, this is the amount of arguments having passed to the function, then charstar argv. Charstar argv is just an array of strings to the argument values. Now, don't worry what star means, I'll explain that in a minute. But first we're going to print a hello world to the console. Now to do this, we're just going to type printf, and then we're going to type hello space world exclamation mark. And then we're going to do \n to print a new line at the end of that statement. End it with a semicolon and save the file. Now we need to compile it. To do this, you're going to use a compiler. You can use one called GCC. If you have Ubuntu or Linux, you can just install Build Essential and you'll get access to the compiler. Now we're going to type GCC helloworld.c, and this is going to compile it. Now it's going to compile it to a file called a.out, and if we execute a.out with /a.out, you'll see it will print hello world and then a new line. Now you can also change your compiler to get more warnings. So if you do -W all, then it will give you warnings when you do things which might be a bad idea. It's important to do this because otherwise you won't be told when you do potentially sketchy operations in your code. So we're going to use -W all from now on. Now I'm going to explain what this charstar argv is. Now this is an array of strings. A string in C is just an array. So it's going to be letters, 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 letters. Then at the end of a string is a 0. This is called the null terminator. So for example, this string in printf of hello world, it's going to be H as a character, then E, then L, then O, so on, so on, so forth. And at the end a 0. Now I'm going to explain what the charstar argv means. Now this is just an array of strings. A string is a charstar, which is just a pointer to a segment of memory with a bunch of letters in order. So it'd be, in the case of hello world, HELLO, ... Then at the end of a string, to tell you it's ended, is a 0. So we're going to create a string. Now I said that a charstar is a string. This is true to an extent. However, this is going to be a string in what's called the data segment of the program. So if you study programs, you know that they're split into a few things. You've got the code or the program, so that's the assembling instructions like move L1 to whatever and all the registers and whatnot. And then you're also going to have the data, so this is things such as string constants, global like static variables, and stuff like that. Although global static variables will probably be at the bottom of the stack, but let's not get too bogged down with that. So anyway, charstar string data, this is just a string in the data segment. We're just going to set this to hello world. Now in C there's something, there's an operator called size of. Now this will print the size of a type. So if you do size of an int, it will say 4 because an integer is 32 bits or 4 bytes. And if you do something like size of a pointer, so charstar, it will say 8 because it's a long integer, 64 bits or 8 bytes. So charstar, when defined like this, will be a pointer, so it will be 8 in size. However, this isn't something you want all the time. For example, you might want to have a string which you know the length of at compile time. Now there's another way to define strings. So we're going to have ourselves string underscore stack. This is defined on the stack, so it's going to be whenever you call this function main, on the stack it will copy the string there. And this is just going to be hello world as well. Now I want you to watch what happens when I print the sizes of these. So if I print f, send ld for str underscore data, \n, when I can find my backslash, then send ld for str underscore stack, send ld, then size of str underscore data, size of str_stack. You will notice that these come with different values. So first one's 8 and the second one is 12. Hello world is 11 letters, but obviously there's the 0, the null terminator at the end, so it's 12 in total. The HELLO, so on and so forth, and the 0. And it's identical with the other one, except that's defined somewhere else. So you're actually just getting a pointer to the data segment, and the pointer is of size 8. Now, if we go back to charstar star, I think we can explain this now. So we're going to print all the arguments. So we know there's argc number of arguments. So we're going to do int I equals 0. I is less than argc, I plus plus, and we're just going to print f the ith %d argument is %s \n. Then we're going to do I and then argv_i. Now, if you don't know how printf works, I recommend you watch a video on it, because it's quite an interesting function. It lets you print formatted strings very easily. So instead of having to do things such as concatenate strings, you know, where you say in Java you might or Python you might say print the space then plus something then plus so on and so forth and build a string like that. You can instead use %s for strings or %d for numbers, and then just put them as arguments at the end of a function. It's called a variadic function, so it takes an unspecified amount of arguments, which means you can do things like this, where I just print %d and then %s here, then the %d gets replaced with the I, and the argv_i will replace the %s when it's printed. I know that's a bit of a weird way to explain it, but I'll show you. So here we go. So we call it with zero arguments, but interestingly, it's saying that there's one argument, the 0th argument being a.out. Now this is the executable that was called. So when you do something like, let's say you're on the command line and you type gcc whatever, gcc is the command of the executable, so it's just that in the path in Linux. So your 0th argument would be gcc, although that might get replaced in bash to an absolute path sometimes. But let's not get too bogged down with that. So if I call a.out with some arguments such as hello from arguments in the console, you'll see it prints all of these here. And each charstar so charstar star is just a pointer to a charstar. And now what I mean by a pointer in this thing is it just points to the 0th argument, and then the next argument will come directly after it in memory, and then the next one directly afterwards, and the next one directly afterwards. But that's actual pointers, not the entire string. So you're going to be looking at a number for the first one, just say like OX27 or whatever, which points to the 0th argument. Then the next one, OX something or other, which points to the next one, so on and so forth. So you would just see a set of addresses in memory, which would be your charstar star, which is an array of strings. But notice how the strings aren't sequential in the memory. They're pointed somewhere else on the heap. Now, that's quite different compared to if you do a char... will be a const, like star, char, square brackets or something. I can't remember the syntax for an array of predetermined length strings, but then it would be in sequential order, but that's quite advanced, so we won't touch on that now. So all you need to know is that charstar star is an array of strings. Each element is a char star, which is somewhere else on the heap entirely. Right, now when I was filming this, I did film a part 2 about malloc and free and further stuff on strings. However, I'm going to split that into a second video because I want to elaborate on it deeper. I think that's the best thing to do. So tune in some point for that. Like and subscribe, I guess. Thank you very much for watching. Cheerio.